Thank you very much. Well, I hope you're all prepared to be very disappointed, because that really does make me sound much better at things than I actually am. So hi, my name is Katie. I would describe myself as an occasional bug bounty hunter, cybersecurity YouTuber, lecturer. I also work as a principal security researcher at a company called Traceable. And I am still awaiting my my award for inventing more hours in the day, and certainly not half doing a lot of things. So today I'm going to be talking about APIs, but specifically API hacking. Now, any single time someone is like, I want to get into hacking, where should I start? I always recommend APIs. And I actually think APIs are some of the most accessible places to actually get started in hacking. And certainly if you've never had a go at hacking, or it's maybe something you're interested in, but you've never had the opportunity or like the desire to kind of go deeply, or maybe it's been super intimidating for you, I hope this talk will inspire you to have a go, because honestly, it's not that hard. Like APIs are full of security vulnerabilities. They are often built incorrectly. And honestly, from an attacker's point of view, it's kind of easy. So what is an API? So fundamentally, an API is a type of application that is not designed to be consumed by humans. So this is not an application that you interact with. Instead, it's meant to be consumed by other applications. The best way to think about it is kind of like a waiter in a restaurant. They act as an API between your table and the kitchen, right? So they kind of handle the communication of what you wanted. And there's a lot of reasons why organizations and developers like using APIs. But fundamentally, it just allows them to kind of combine their efforts. You know, typically, if you're launching a new product, you're going to need an app. You're going to need lots of apps, because you're going to need an iOS app and an Android app and a web app and maybe a desktop app and maybe a Mac app and a Windows app. And that's a lot of apps. And you should read that as that costs a lot of money for developers. So instead, if you develop an API and then everything connects via the API, hey, that is like 2 whole jobs that you don't even need to hire for anymore. Now, sometimes these APIs are developed like intentionally for third parties. So think about the Twitter developer API, the Reddit API. They're designed for kind of integrating their thing with other organizations. Now, typically, when I talk about APIs, I'm not talking about developer APIs. I'm talking about APIs that kind of keep applications moving. They are usually for something like Twitter will have its own API in the background. So the way APIs talk to each other is using something called Json. So Json looks really scary. And every single time people are like get overwhelmed with API hacking, it's because they just see JSON as a response instead of like HTML. I promise you, this is much easier to read than any Bootstrap website I've ever seen. It uses a key value pair. So it's this way of representing complex objects in text. Now, if you're not familiar with JSON, but you want to do API hacking, this is something you're going to have to learn, because JSON is basically what every API connects via. Most APIs are RESTful APIs. GraphQL uses JSON. You will see it everywhere, especially when you know what to look for. You're like, oh, that's a JWT token. That's JSON. That's base64 encoded JSON. It really is everywhere. There's a lot of different types of API, and they all have their kind of uses. So there are RESTful APIs. This is your bog standard default API. You have batched APIs. These APIs take a bunch of requests and squash it down into a single request. There's things like GraphQL. And if you're curious about GraphQL, I did a talk at OWASP London during the pandemic about GraphQL. So you can find out more in that talk. But there are also SOAP, which is kind of your legacy API. and gRPC, which are remote procedure calls, which quite frankly are the scary kinds of API. So maybe don't look at those. I'm going to be focusing on RESTful APIs because RESTful APIs are fundamentally the most common APIs. When you see these, you see them everywhere. Like I had a problem. I was booking some flights and I couldn't select my seat. So I went into the web browser console and it's an API. And it turns out if I just fiddled with the request, I could book those seats I wanted, even though the application was broken, which I certainly do not condone doing. So CRUD. CRUD is a really nice term that developers use when talking about the like fundamental things an application does. So an application is made up of resources. You're on Twitter, you have tweets. You're on Facebook, you have posts. You're on Reddit, you have subreddits, you have users, all of these resources. And then for each of these resources, you have a unique API endpoint. And those endpoints are the create, the read, the update, delete, CRUD. Now, what you may notice from seeing this is that, hang on a second, applications have a lot of functionality. Think about Just Eat. You've got takeaways, you've got orders, you've got menus, you've got menu items, you have add-ons for those menu items, you have the idea of a basket, having two baskets open with two different restaurants, you've got drivers, you've got pickups. And each one of these needs at least 4 API endpoints. At that point, you are looking at a massive explosion in your attack surface. And that is why APIs are so hard to do security on, because they end up being huge. And what ends up happening is when these APIs are massive, you end up in this situation where developers and security teams don't really know what's going on in an API. They make a small mistake a year ago and it doesn't come up for months. And even then it comes up on like a random test. And even then it's only in specific circumstances. You just don't notice things. On the attacker point of view, it's really annoying because we need to guess a lot of names and a lot of the ways APIs work. Now, if you think about like your prediction, well, okay, if I'm looking at an API and it's for Just Eat, I'm going to have orders, I'm going to have restaurants, I'm going to have drivers, I'm going to have accounts. And if you're looking at YouTube, you've got videos, you can start to predict these things. However, they are often like super customizable. Now, one of the great ways you can look at APIs is through developer APIs. Now, I certainly have not chosen these particular developer APIs for any reason. Certainly not. But developer APIs are often available for free. And the idea is that you integrate with their API and you integrate their stuff into your product, and then they get wider adoption of what they're looking at. So this really helped Twitter and Reddit become such big social media companies because a lot of companies integrated Twitter searching for trends or APIs on Reddit for seeing like sentiment across different subreddits. And then, of course, once they've built their business model around that, you then start charging for it. RESTful APIs. So RESTful APIs are really challenging to enumerate because you have to guess the resource names. Now, there are some word lists, and certainly if you come and be like, Katie, what's the API word list that I need to use? There are some good ones. Kite Runner is very good. I understand that Kite Runner's development has kind of stalled. So I don't know if the tool still works, but it does have this massive list of API endpoints that it's kind of got procedurally. Now, I also have some videos about API word lists and about all of these, how to use these tools. I will be honest with you, I don't use them. People ask me for the videos on them, so I make the videos because YouTuber. But actually, I don't use them. My version of reconnaissance is click all the buttons. The main way I discover APIs is simply click the buttons. So for example, you'll often be in a situation, like say you're using Zoom, And you probably only use Zoom to join a meeting, or maybe like you unmute your microphone, you start your camera, whatever. Did you know Zoom has this entire feature about whiteboards and clips and applications that can go into third parties? Because I do, because it had a vulnerability in it. And with all of that, you just keep on pressing buttons, and they're all API endpoints. So if anybody asks why you're getting a takeaway midweek at like 9 p.m. because you can't be bothered to cook, that's API reconnaissance. People often ask me about my API hacking toolbox as well. Again, crushingly disappointing to actually hear this. I don't use like a big toolbox. I don't use complex tools. I use Burp Suite. I don't even pay for Burp, right? I use the free version of Burp, and that's it. So fundamentally, I'm really interacting with this API as like literally just raw requests and responses. The only addition I do put onto this is this one on the side. It's called PwnFox. There's also Autochrome as well. It colors the tabs. That's it. That's all it does. It makes the tabs different colors. So when you're logged in with different accounts, you can check to make sure you haven't accidentally logged into your attacker account instead of your victim account, and you haven't reported a security vulnerability, which is absolutely not an issue at all. And you've just wasted like 10 people's time reporting it because you're like, that's super serious. Instead, it's colored tabs. Now, in terms of what vulnerabilities to find, OWASP does have the OWASP API top 10. And broadly, I think you can put them under these like 3 categories. So category 1 is access control. If you take nothing else from this presentation at all, broken access control is the most common finding on any API. Like I will go into tests with multi-million-dollar like security teams that have a security budget that is like through the roof. They'll have access control issues. I will speak to a small business and they have access control issues. Access control is the number one. And if you're looking like, I want to get into bug bounty hunting, I want to get into hacking, what should I look for? Access control issues. I'll talk a bit more about it. They're kind of annoying to hunt for, but they are very, very common. And confusingly, the OWASP API top 10 has it split up into 3 different ways. They are fundamentally the same thing. You can do something to an object you don't own. You can delete somebody else's tweet. You can delete a post on a forum when you're not an administrator. You can access a property, so credit card information of an order that's not yours. The next is identity and authentication. So really, this comes under broken authentication. There's lots of ways this can be broken in APIs. Saying that, most of it is just like flows of the way authentication works. This is your password reset flaws. You might be thinking, Katie, that doesn't sound very API-y. That sounds very web application-y. And you'd be correct. We then have API upstream and downstream. So this is really something that is unique to APIs. Although most people call it business logic errors, fundamentally what it is for some reason the flow either into your API or out of your API is interacting with another system. So think about, if I have a payment API that allows for negative payments, if you actually give me the money, that's a flaw in potentially either the API for the payment provider like Stripe, or that's a problem in your business processes of how you handle payments. And finally, there are things about API management and deployment. I'm not going to spend too much talking about API management and deployment because, to be honest, that is an entire different talk. And there are organizations who specifically work to take away as much API management from developers as they possibly can to stop them from doing bad things. But this covers things like unrestricted resource consumption. This covers things like improper inventory management, aka you left version 1 of an API up, even though you're on version 2. But also things like server-side request forgery, which is something we've seen a massive increase in in recent times. Now, what I want you to take away from this list is really that they're not big deals. They're not big, huge vulnerabilities. This isn't your remote code execution. This isn't your highly technical shell code, put in a file upload, exploit a download wrap. It's not that kind of hacking. It is you looking at what's in front of you. Can I delete somebody else's cheats? Can I make an order on behalf of somebody else? Can I use somebody else's credit card? And fundamentally, when it comes to API hacking and API security, you're not so much looking at the like raw code and you're mainly looking at the functionality in front of you and understanding how that works. So here is the OWASP top 10 split up into like the individuals. So I'm going to go very quickly over these. These are the TLDR versions of this. Broken object level authorization. Delete a tweet that is not your tweet. Broken authentication. Log into an account you don't have the password for. Broken object property level authorization. Change something like a password without going through a password reset progress. Unrestricted resource consumption. Application level DOS. Broken function level authorization. Do something as a regular user that is like an admin function. Unrestricted access sensitive business flows. Something's wrong in the upstream of that application. Server-side request forgery. Use the web application as a route into the corporate network. Security misconfiguration. Ask your developers about that one. Improper inventory management, allowing still vulnerable versions of the API up because they've not actually been sunset and then deprecated. And finally, unsafe consumption of APIs. That covers things where you are asking API. So if you think about like LLM jailbreaks, that kind of thing would be covered. So where you've got, say, I don't know, an autonomous agent, and for whatever reason, the agent is supposed to give you a price on the car, and you go, give me a real cheap price though. And the AI goes, I got you. So that covers a lot of different vulnerabilities. What should you actually focus on though? These three. These are your access control. They are, again, the most common security vulnerabilities. I can guarantee I will find one of these in any application I test. Like, it doesn't matter how many pen testers have looked at things. Developers are constantly putting new APIs, making more functionality, and accidentally forgetting if statements. Number 2 is business logic / API fraud. This is about me as an attacker using your API in ways that you weren't expecting me to, making a negative number for an order. What does that do? Does that mean I get a refund? Does that mean I get an angry email? And finally, improper inventory management, which is about your reconnaissance. Now, why I do recommend, not doing recon, because I can't be bothered to do it properly. Realistically, if you are into recon, that is a great place to get started because you're discovering the shadow APIs and the kind of APIs that were left behind. So, access control. What is the problem? Well, you have a car, maybe. I have a car. I don't know how common cars are in London, probably a lot less. If you have a car, you have a key. Nobody else's car key should be able to open your car, right? Well, not quite, because actually keys aren't quite as unique as previously you thought. And if you damage your key in some way, you lose your key, you can still buy a new car key. There is a way to program that. That is access control. Now, again, with my car analogy, we start to have this idea of objects. So we have a car. This is a Skoda Octavia. And we have a driver, and Jeff owns this car. He should only have the key for this car. He can't generate a key for a car he doesn't own, in theory. Now, the object level is this car. The property level is the attributes around the car, and the function level is the driver. AKA, I can't just go up to anybody's car and start driving it. I don't own that car. That's your functional level. You can't, as a random passerby, just go and start somebody's car. That's the object level. And you can't go in there and like remove all the badges off the car and then replace it with something else and then adjust the property level, which is a really confusing way of like separating the same vulnerability in 3 ways. And it gets worse because then you also have rent-a-car operations. Now, in rent-a-car operations, you actually do want to open somebody else's car because they only own it for so long. And that's when you start to have tenancy and SaaS applications. And then your simple CRUD of create a new task, delete a task, then becomes, well, are you in the right organization? Do you have the right permission levels? And that is fundamentally what I am hacking. I am checking that. There's a hacker, his name's Douglas Day, or Archangel D-Day. He has a really great way of putting this, which is look for no's. So look at where an application says you shouldn't be able to do something and check whether or not that's the case. And when it comes to API hacking, that's kind of fundamentally all we're doing is looking for no's. So here's my TLDR of all of the access controls. Cross-tenant, accessing another tenant's object without being a member, accessing a OneDrive of another organization. Bowler, accessing an object owned by another user. Broken function, accessing an admin function. And broken property, being able to change or view a property without the proper method, bypassing like the change reset requiring your previous password. And that's kind of how I hack things. Oh, actually, I'm going to skip these. Wow. Okay, right. So I'm going to play a game if it works. I don't know whether or not it's going to work, but I'm going to play a game. It's called Name That Vulnerability. So you know about the same amount about API hacking, if not more, than I did when I found my first API security vulnerability. So hopefully you should be able to scan the QR code. I promise the QR code is safe. Or join. I do swear this is a perfectly legitimate code, but hopefully you'll be able to join the presentation. I'll give a few moments. Oh, I think it's not working. Sorry. That's what happens when you do live demos. Anyway, that's fine. I'm going to just test your API security knowledge. I'm just going to ask you to stick your hands up. So you're testing an online store that sells clothing using a payment provider API to check out. Think Stripe. You can include a cross-site scripting payload in your address when checking out with a third party. In the shop's admin center in Shopify, the XSS payload fires. Put your hand up if you think, I'm going to give you the 4 options first. That is broken object level authorization. That is API upstream, downstream problems, or it is authentication problems, okay? So those themes. So is it access control, API upstream and downstream, or broken authentication issues? Stick your hand up if you think it is access control related. Put your hand up if you think it is related to the API upstream and downstream. And put your hand up if you think it is related to authentication. Okay, interesting. You could probably make the argument that it could be. But definitely API upstream, downstream. I think that is something that's often really overlooked, which is kind of unique to APIs because they are so interconnected. Okay, question 2. A mobile app that easily lets you send and receive money using email or phone numbers. So think, wow, like PayPal, I guess. So you can make a transfer from account you're not logged into only if you're logged into the receiving account. So you could send yourself money, you can't send somebody else money. However, it's all coming from an account you don't control. Put your hand up if you think that is authentication related. Put your hand up if you think it's access control related. Put your hand up if you think that's API upstream, downstream. And stick your hand up if you think that is API deployment related. Yeah, it's access control. That is classic access control. And that is actually the first vulnerability I ever found. It really was literally that easy. So I'm going to do one more little quiz question. And then I'll open the floor to Q&A. So it's a blogging application. You notice that when you're testing, the plugins have a hard-coded secret for a JWT, which is a JSON web token. You're able to spoof a valid JWT for your own blog or for others. Stick your hand up if you think that is access control related, API versioning related, authentication related. Yeah, absolutely right. That's a problem with logging in and logging off. So thank you very much, everybody. If you have questions, please feel free to ask me. If you don't have questions,
I'm sure there will be questions. All right. Okay. 1 second. I need.
throw the mic. Is that an actual throwable mic?
Thank you. Hello, hello. Yeah, hi. This is Amit here. A very interesting talk on the access control related top 10. I have a query on the GraphQL API.
Yeah.
This is a modern way of nowadays using enterprises start using GraphQL. So what do you think the risks to the GraphQL architecture, and is there a specific risk which you want to share to us?
That's a really good question. So if you've never seen GraphQL, the idea is that instead of using APIs as distinct endpoints, you instead tell the API what you want, kind of like an SQL query, but it's written in this. It's really cool. If you've not seen it like being used as like a former developer who used to make APIs, it is so cool. But it does have some issues. So obviously you expose quite a lot of your API structure simply from GraphQL. A lot of people say that's a security vulnerability. That's not a security vulnerability. GraphQL introspection is not a security vulnerability at all. It is intended as part of how it works. But honestly, when it comes to GraphQL, there's kind of no difference. You know, some of the vulnerabilities I found in GraphQL servers are things like application level DOSes, because you can use nested queries. You can go backwards and forwards and put it in a recursive loop. That's really fun. It breaks a lot of GraphQL servers. And the other side is just access control issues, you know, especially when it comes to the property level. I see it a ton in GraphQL APIs as well. Honestly, they're kind of, while as a developer, I love them, they are such a cool way of consuming an API. From a security testing standpoint, it's just another way to interact with them. You know, you have to learn the query language. You kind of have to learn its like little quirks, little like things that make it a little bit weird. But actually, fundamentally, it doesn't change the way we interact with an API more than just it's a different language. In terms of testing GraphQL, I really recommend the GraphQL introspection query. You can find it everywhere. There's a good one on Payload All the Things. They've got the different encodes. And then getting something like InQL or getting one of the GraphQL add-ons into Burp just to help you with the syntax highlighting, and so you can kind of structure it. But honestly, the difference is like academic from a security testing standpoint. It's just a different way of interacting with it.
Katie, and just to add that Katie did present a talk on API hacking back in the pandemic times, which is available recording on OWASP London YouTube channel, and actually does have a whole section about GraphQL. So if you're interested,
and a demo as well.
The live demo. Right. Next question. Someone. Okay. There was a question online. Okay. Could you please share your thoughts on implementing secure API access using FAPI2 or FAPI2, which is financial grade API? Do you know anything about it?
That is very, very precise, and I do not know it off the top of my head, I'm afraid. However, I will say a lot in the finance space when it comes to regulation, when you've got your PCI DSS or your open banking or whatever, quite a lot of those regulations kind of build in security as part of it, but the actual implementation of it, a lot of them are being way more flexible on how you do it. Like PCI DSS 4.0, for example, the main changes in that version are all about like how you can be a bit more flexible in implementing those requirements, which I think is good to see. While I don't have like a specific answer for financial APIs, I will say that I think the industry in general is moving to a better place of not requiring outdated security practices and giving that flexibility back.
Great. Thanks, Katie. There's one more question online, which was, what was the biggest security flaw you have found?
The biggest? Okay, right. So it depends on how you ask the question. I will give you the most impactful one, and I will tell you the one that paid the best. So the most impactful finding I ever found, I was testing an airport application. I can't go into too much detail on what exactly it did, but you know when they have like D-Day, like memorial events, and they'll get like the red arrows to fly over or historic aircraft to fly over? It was basically a request to like, oh, could you please, you know, fly over my event at 12:30? I've got like a bunch of, you know, D-Day veterans that I'm hosting. It's that kind of thing. So you could request that airplanes fly over. And when you provided these requests, you had to tell it some information. So who you were, you know, are you important enough to ask if, you know, some, like we can fly like £1 million historical artifacts above you, you know, is this going to be a big event, that kind of thing. So you had to include some details about the event, your name, who the event was for, the nearest airport, the size of the runway of that airport, and a bunch of other details, you know, what services are available at the airport, that kind of thing. I was like, okay, great. So I was testing it and I found a broken access control. Much like an airline booking system or like a hotel booking system, you just had to give it your last name and email address. If you had that information, then you could see basically any request for a flyby. Obviously, that is an issue in itself because you can go onto LinkedIn and find those real easy. But what you were able to do from that is change the airport information. Now, does that matter? Well, it turns out if you say you've got a really long runway and you don't, the planes just kind of keep going. And obviously for historic aircraft, that might be the only aircraft left of that generation. That might be tenderly cared for by volunteers in their free time. That might be thousands of pounds of like investment into actually getting it flying, let alone the cost of the aircraft itself that is often bared through charities, right? But you could change the length of the runway. So I could go in there and say, you know, my nearest runway is Manchester Aerodrome, and we have a big enough runway for a 747. And the planes just land and keep going, and you cause a massive air crash and you kill people. That's the worst vulnerability I've found in terms of like actual human impact. And when I was testing this, I had this realization. I'm like, oh my God, I could have killed somebody. And then I received my £5,000 bounty and I was like, oh my God, I could have killed somebody. But in terms of my best paying was actually an interesting GraphQL vulnerability, which is one of my favorite vulnerabilities I've ever found. I fingerprinted the exact version of a GraphQL server and interpreter that an application was using error messages from their JSON parser. And I felt like an absolute genius. I was like, my God, I am it. I'm a hacker now. That's like my best find. And that paid a bunch. So I was really happy about that too.
Any more questions? Yeah, that's a question here.
Hello. So for someone aspiring to do bounties, bug bounties, one piece of advice I've heard is to combine something like the resources on OWASP and then to try and match them up to particular scopes within something like HackerOne. Could you expand upon that sort of basic framework for dealing with bounties at all?
So I'm going to answer this question in 2 parts. I'm going to give you some better advice because I don't think that advice is very helpful for most people. But then I will attempt to like explain that advice a bit more. My number 1 piece of advice, if you want to do bug bounties, is just go do it. I cannot tell you how little preparation I had before I found my first bounty. I had never seen a request before. I was a web developer. I used to make APIs, and that's how I kind of got started. I have a degree in computer science, but I didn't know anything about cybersecurity. I had the option to take a cybersecurity unit while I was at university, and I was like, nah, that's going to be too hard. I'm just going to take the web dev unit instead. I mean, great for like optimizing my grade, but how much that actually helped when the company I worked for had a security incident and my only response was switch the server off, probably not that helpful. But I was really unprepared. Like I knew absolutely nothing. The fact you are at one of these events, you are already more qualified to be doing bug bounty hunting than I was. Like I basically ended up here accidentally. And when you speak to a lot of bug bounty hunters, that's kind of a very repetitive story. A lot of people aren't engaging with communities like OWASP. If they did, it'd be a huge advantage. But honestly, the best advice I can give is just have a go. Just get started. There's no critical mass of knowledge that you need to be able to find bugs. You just need that kind of, oh, I wonder what happens if I do whatever. Now, I think there is something to be said for like the idea of a very academic approach to going, well, here are the OWASP top 10. I'm going to search for the OWASP top 10. Or here's the OWASP LLM top 10 and taking that approach, or using something like the mobile testing guide, the web testing guide that's available. It's very much focused more on pen testers who need that like broad scope of issues. But saying that, I am always for the idea of like using knowledge. Like a lot of people say, oh, you should start with one vulnerability and hunt for that everywhere. Terrible advice. Look for a bunch of different vulnerabilities, constantly be upping your AppSec knowledge of vulnerabilities. And one of the best ways that I found to do that was actually making YouTube videos, because I would look at disclosed reports and be like, how can I explain that to my audience? And that kind of forced me to really learn those topics deeply. Now, I think there's a lot you can do with that idea of, okay, take the OWASP knowledge the same way, look at disclosed reports, look at things like the OWASP top 10 and the web testing guide and see where those kind of intersect. Like, are they doing a formal recon process? Are they searching for cross-site scripting or whatever, right? Injection type vulnerabilities. That is a way of getting into it. I will say most bug bounty hunters I know are some of the most chaotic people. Like, they're completely not organized at all. The pen testers are much more organized than we are. We like roll up to a conference, spend the first day in our rooms hacking, and then by day 2 we're like, oh, I found a critical vulnerability on Amazon last night. It was really cool. No, I can't tell you anything about it. I signed an NDA. Oh my God, I just got $100,000. Let's go to roulette. Genuinely happened to me. Like, I was like, I live in a completely different world to these people. But yeah, bug bounty hunting is by its nature a little bit chaotic. And that's kind of the advantage of, I think, bug bounty hunting as a security program. The idea that, hey, you know, attackers aren't using the OWASP web testing guide. They're not using the mobile testing guide. They're not using the OWASP top 10. They're like just finding vulnerabilities. And the power of that is very much on the in the crowd, if that makes sense. So hopefully a very long-winded answer for your question.
Excellent. Thank you very much, Katie. Let's thank Katie for an awesome talk and fantastic insights.